Welcome back. In this segment, we're going to do a drill, and I'm going to have you implement both insertion and appending into a linked list. Okay, so let me just remind you where we are. We defined a class called node, which right now just has a single constructor. That's my init constructor. It takes as input data. What are you going to store in each node of the linked list? And it creates a single node where it wires up the data, and then it says that the next is equal to none, and it's somebody else's responsibility to wire up the list. The node itself is simply doing the job of storing the data, and the wiring up is going to be, well, our responsibility with insert and append. So instead of doing that manually by defining a bunch of nodes and manually setting them up, we are going to write an insert after and insert at end, which should be relatively similar. I've given you a print list function because this will make it a little bit easier for you to see if your code is working. So what you'll do is you'll create a list, add a bunch of things, both at a position at the end, and then print the list and make sure everything looks the way it should. So let's just go through that print before. We've already done that, but it's a good exercise. So this is a member function of the class node. It only takes a single input, which is the object itself. It sets a variable called cur to self. So you print the list starting at some node, presumably at the head, because if you want to print the whole thing. Cur now is pointing to the first element in the list, while cur does not equal none. So as long as there is something in the to be printed in that node, then I'm going to print cur.data, reach into the data field associated with the node. And just so I don't have all the carriage returns, I'm going to have the delimiter be a space, move on to the next node in the linked list, cur equals cur.next, keep looping until cur equals cur.next gets me to something that's empty. I stop, and then I print a carriage return at the end. Okay, so same thing as we saw before, just iterate through the list, going through the next pointers. And now your job is to please write insert after and insert at end. So the way insert after is, it's again, remember this is a function of the class node. So what can call it? Well, there's any node. So when I call it with some node, insert after, it should insert after that node, whatever that is. If it's the head of the class, head of the list, that's fine. If it's some other node in the list, that's fine too. So I'm going to call insert after from a node in the list. My job in this little function is to insert a new node. That's what's being passed in. So you have to create a node, pass it in, being called from another node, and you're going to insert after. And then inserted end is going to insert at the very end of the linked list like an append function. Now, let me give you a hint. Once you write insert after, this, with a little bit of help from this code up here, should use this function. You shouldn't have to start from scratch. So for the drill, please write insert after, make sure it works, and then try to write insert at end. And then when we come back, I'll show you my solution. All right, I hope you got that. And so let me show you my solution for insert after, and then we'll do insert at end. Okay, so here it is, 3 lines of code. Actually, not too bad. So let's, I'm going to walk through this, but let me just show you how I'm going to make a list first. So I'm going to say head equals node with some string in it, A. So that will create this little node right here, A, with none in the next position. Why? Well, when I call the constructor here, it comes up to here, it sticks A into the data field, that's that right there, and it says that next is none. So my linked list right now, with head as the variable, simply has one node in it, A and nothing else. Now, head is the head of the list. So when I call this member function, I'm going to call it from head, and I'm going to say, please insert after the head the node B. Notice I'm calling the constructor here. It's not B. This thing doesn't take a string, it takes a node. So I've got to call the constructor. That's this call right here with the letter B. And what's going to happen, and we'll walk through the code in a second, is it's going to create a new node and wire it up. So this next variable should point to B. This B should be none because that's what happened when we called the constructor. All right, then I'm going to say insert after the head C. Now be really careful here. What node is calling insert after? It's not this node, it's this node. So when I say head.insert after C, I want to insert a C right in there. All right, now let's see how that works. Okay, so we're going to call the constructor node of C, so that goes off, creates an object, and then it passes that into this thing right here. Self, of course, is going to be head, that's A. So now let's go through the code. So first things first, I need to wire up a new node after A. So this thing is going to have to get out of my way. So the first thing I'm going to do is I'm going to just hold on to it into a temporary variable. So self is what I'm calling insert after with, that's the head. So I'm going to say temp is equal to self.next, that's that B node. Why am I doing that, by the way? Because I'm about to rewire this next to my new node, and I don't want to lose this. So if I take this next pointer and I shove it to something new and I haven't held on to this, it's gone. So we're going to hold on to it, so that's going to be temp. And then I'm going to say self.next is equal to the node that was passed in. Good, that's what I want. Now I've got to do a little bit more work, so I've got to take that B node and shove it back in over here after this. Now, keep track of the variables. Self is what I called this function with, the member function, that was this. Node is the new node. So what do I want to do now is I want node.next to be whatever used to be in that position. So node.next equals temp, and I get everything here. Notice something very cool here, by the way. This list only has 3 elements. But if this B had 100 elements after it, no problem. Everything still works. Right? So imagine I had a list with A, B, C, D, E, F, G. I would have said temp equals self.next, and I would have grabbed that element, which itself points to the next node, the next node, the next node, the next node, and I've pulled all that aside. And so here's where you can see the big O of 1 runtime complexity, because all I have to do is create one new link here. Well, I have to hold on to a temporary variable, create a new link, and then rewire. So there's no loop construct here. There's nothing that depends on the length of the list. It's just literally moving a couple of connections, and therein lies the power. And now you can see very explicitly why insert after is big O of 1. Just 3 commands, doesn't matter how long the list is. Okay, good. Let's go look at insert at end. Okay, and as promised, I'm going to take advantage of this. So how am I going to do that? And by the way, there's a couple of ways you could have done this, but let me go ahead and show you my solution. So same thing, that's going to be the node we call it with, let's say it's the head, and I'm going to pass it a node. So head, I set A to be the first node, inserted N with node of B. Goes off, calls the constructor, creates a node with B in it, and I want to put that at the end of the list. All right, so what does it mean to put it at the end of the list? It means I've got to make my way down the list, right? Okay, so cur is equal to self. Good. Now, while cur.next does not equal none, that sounds pretty familiar, that's what we did with the print, cur equals cur.next. So what am I doing in this little loop right here? I'm iterating through the elements to get to the last element. So it's the same way I did with the print. This is exactly the code for the print, except I'm not printing anything. So I start with the head of the node, and I say cur equals cur.next, cur equals cur.next, cur equals cur.next, and eventually I get to the point where cur.next is equal to none, not cur. So what does that mean? It means I have a node whose next pointer is empty. Ah, that must be the end of the list. So notice a little bit of a difference here. I'm not asking if current is none. That means I've literally wiped myself out. I'm asking if the next pointer is none, in which case I am at the end of the list. And if I'm at the end of the list, then that's the node that I want to insert a new node after. So if cur is the last node in the list, then cur.insert after of node will insert a node at the very end of the list. Now, what's the runtime complexity of this? Well, that's big O of 1 right there. That's, of course, big O of 1. We've just determined that. But what's this little loop? Big O of n. Getting to the end of the list is expensive. Why? Well, I only have a pointer to the front of the list. Of course it's expensive to get to the end of the list. I've got to go through the whole list. So it looks like insert is not the windfall we thought it was. Inserting after the first node or a node that you already have access to, super easy, big O of 1. But if I want to get to the end of the list, it's expensive. And it's expensive because the links only go one way, and I only have access to the first element of the list. And that little sort of bump in the road is going to lead us to doubly linked lists and so-called circular lists, where from the first element in the list I can get both to the end and to the second element equally easily, and that's going to help us with that insert at end. All right, I hope you got the drill. If you didn't, here's my suggestion. Take a little break, maybe a couple of hours, maybe even a day, and go back and redo it. It's okay if you've seen the answer, but put it aside and try it again. It's really important to get through these exercises because it really exercises the muscles. And if you didn't get it, and it's fine, just make sure you understand why, and we'll try next time again. All right, that's it for this lecture on singly linked lists. When we pick it up, we're going to talk about doubly and circular linked lists. So a little bit more when we come back.